Thank you everybody for coming. This is 5 years that this group exists, and a lot has changed since the group started 5 years ago. We started as a regular function and service developers in the AWS cloud, and then we expanded our interest into managed services from other vendors and clouds. And personally, I believe that 5 years later, the compute problem has been solved using serverless tech. Not everybody is using it, but there is way more mess in the data space. And because there is a mess in the data space, there is opportunities for jobs. And also often like data jobs are closer to business, which means they're closer to decision making, which means they're closer to money. So there is more of those jobs. And if you find them, they're going to last longer and be better paid. And so that's why this meetup has four talks, two traditional, now it's a traditional serverless talks. One is by our friend Mike Apti of AWS. He was with us. Thank you for supporting me at the first meetup 5 years ago. And he's going to talk about architectural patterns, event-driven serverless architectures on AWS. And then we have another cloud talk by Hugo from Google. It's going to be DevOps CI/CD pipelines talk. And two talks are looking forward into the data space where the mess is. You're gonna the talk by Nadji of Infostrux is going to resonate with people looking to switch from DevOps into the DataOps, into the data world. And then the last talk about from Jacob from Montreal Analytics is going to be about the data modeling. Why data modeling is important? It's too easy to make mistakes in the data world. And the old knowledge that I had to go to basement to get my old books, like from Kindle, is becoming popular again, but this time it's going to be used as a language of a business, like what API was developer data models are for business. So we are going to help you position yourself using the knowledge service and the cloud into the data space, and then do it properly. So we don't create more technical debt and more mess for the others. And so that's kind of overall theme of the meetup. However, because Jacob is from Europe, we had to start in opposite direction of the talks. And for the people who come here from the data groups who are not interested to understand what is under the hood of the car of the cloud data warehouses they're going to be using, they can leave late. They can leave after first hour. Each talk is around 30 minutes with Q&A. But the bribe is if you stay until the end, we're going to do free raffle of any of the mining products. And there is so much you can learn from this company. So I hope you stay with us. Thank you, everyone, for coming. And thank you, Jacob. Thank you, Nadji. Thank you, Mike. And thank you, Hugo, for presenting. So, Jacob, please take it away. I'm stopping presentation.
Okay, great. Thank you for the great introduction. Okay, just let me get this screen share going. Okay, great. Thank you, Daniel, for the great introduction. Very fun to be here, especially for the 5-year anniversary. I was thinking about it, and it's not quite 5 years, but about 5 years ago, I was using the serverless framework for the first time, and actually the primary time that I was using it for deploying Lambdas, and it was for not quite a DBT use case. It was for a data modeling use case. It was kind of deploying a bit of a self-constructed. This was back at Dialogue, a telemedicine company based out of Montreal. But it was for deploying a data transformation infrastructure. A lot has changed since then in terms of approach around kind of data modeling and modularity of some of the ways that certain things are constructed in the way that the team there and a lot of the teams are thinking about data modeling and thinking about constructing data models and maintaining data models. But one of the cool things is a lot of the underlying infrastructure has generally stayed the same. The Lambda approach, the serverless approach, really thinking about even data workflows as infrastructure as code, thinking about how we can have a proper division. That has really affected the way that a lot of other kind of thinking is going in terms of the analytics and data space. We're starting to see more of a convergence there. These analysts are becoming more like engineers, and these data engineers are becoming more like analysts. It's a very interesting space, and I think it's especially interesting to kind of speak with a bit more of a DevOpsy crowd, a bit more of an engineering crowd. So going to dive into it. Today, I'm going to be talking about what we build on top of the infrastructure. Going to be talking about the data model, from data-driven business to business-driven data. So my name's Jacob. I'm the practice lead of analytics engineering at Montreal Analytics. Practice lead really just means that I help lead our best practices internally, training with our internal team, and then externally as well. Externally, that's more, interacting with the community, trying to help participate in Slack channels on LinkedIn, and so forth. Analytics engineering, that's my main focus, but I also have a strong focus in data engineering and generally database architecture, SnowPro architect and some of those certifications. Really trying to make sure that I have a strong foundation in a lot of those domains before diving into some of the solutions that we do. Okay, so let's dive into it. So what are we talking about today? We're talking about the data model. This diagram on the right is a nice visualization that we use. It's a little bit simplified, but it's a nice visualization that we use that kind of presents the modern data stack as a data stack that orients itself around the warehouse. The warehouse sits at the middle, and then you have your bow tie that fans out from there. Across the bottom, not really going to be talking about that too much today, but it's really showing how this centralized warehouse, this kind of centralized data model, this centralized transformation layer can help you bring a lot of things together and facilitate and cover a lot of different use cases when it comes to your stakeholders. On the far left, we have our data. Our data is being generated in a bunch of different ways, and it's being generally being generated in a source-centric way. Data is being generated with the conventions and the structures that are in accordance with that system. If it's your production system, it is going to be in the shape of your normalized production tables. You're going to have all of those tables that have been designed for your application database. If it's event stream data, it's going to be events that have been designed based off of the application that you've created. If it's third-party data, it's going to be data that's coming from HubSpot or from Google Ads or from whatever the platform is. And each one of those systems is going to have its source-centric opinion about what the user is or about what the interactions are. For you to think about a user now, you have a bunch of different users. It's not one single reconciled user. On the other side of things, on those red nodes, we have our stakeholders. Stakeholders are thinking about their problems, their business problems, in a business-centric way. Instead of thinking about a bunch of different types of users, ideally, they would be thinking about a single customer. They would be thinking about a unified, consolidated customer. They would be thinking about that single customer that they can query really nicely and be able to see information just about that customer. We can see that there's a big gap in there. And the modern data stack gives us a nice way of having that transformation layer, the transformation layer that's generally running in warehouse, as a way of resolving that, of a way of implementing the data model, and really nicely just putting a bow on it, creating that customers table for you. Of course, it's a lot more complex than that. I want to kind of peel it back and talk about some of the more technical details of a data model to show why that's not just like rainbows and butterflies. So the data model, the big promise in there is that the data model is going to help you with this age-old problem that analysts like to talk about. How do you translate a business question into a data question? We want to do that in a routine way. We want to do that in a way that is persistent, in a way that's aligned with the business. As Daniel was kind of mentioning in the introduction, data models, in the most ideal sense, are the abstraction layer. They are like an API. They're an API that sits between your data and your stakeholders, and it gives your stakeholders rich access to data without needing to know all of its nuances. That's the big kind of ambitious promise of a data model. What I'm hoping to do in the next 20 minutes is just walk through a more detailed example that helps you show that there's a lot of theory behind that, that helps you show there's a lot of techniques to go through to design a proper data model, and that it's not just let's union all of these customers into one table, or let's just join all of these tables together. There's a lot of things that can go into designing a data model well so that it can be an effective API. So as Daniel was hinting at when he was pulling out his books, there's a lot of different texts. There's a lot of different opinions on it. I'm only going to be able to get into one opinion, and I'm just going to be talking about the Kimball book today. Kimball is a very approachable methodology when it comes to data modeling. It's by far has the lowest barriers to entry in terms of implementing a data model. It can also scale well if well designed. Data Vault 2.0 is also an increasingly popular model, especially for larger scale projects. But I wanted to mention these three. One big table is another kind of fourth one to mention. It doesn't really have a seminal text in the same way that the other ones do, just because it's largely being advocated for by different tools. One big table is really the idea that storage is cheap and you can just fully denormalize these tables. That also has some challenges that you could imagine, but know that these three books are out there. If you're interested in learning more, definitely check them out. Two of them are from the 90s. One of them is from the 2000s. You might be able to tell which one is from the 2000s. Okay, so let's talk about our example. And I will get to that book shortly. That book is going to come up on one of the slides that's coming up. So what I want to give us is a nice example to talk about for data modeling. So let's imagine a checkout flow. Let's imagine that we have a website and maybe we have a few different apps that all have the same checkout flow. You're checking out and you have these 4 different steps. So kind of think of this as the data side of our modern data stack. This is the data that we have. It's overly simple, just so that we have an example, but we have these 4 steps. A user can visit a product page. They can click on a product, they can add that item to their cart, and they can check out the cart. Each one of those 4 things is a discrete event. It's going to have different measurements that would occur while that event is happening. So it's going to have different foreign keys, perhaps. It's going to have different price amounts. There's going to be different measurements of information that would be captured with one of those events. If you land on a page, you may have a referring page. If you are clicking on a product, it's going to have a product ID. There's different bits of information that are going to be included in each one of those events. On the other side of things, we have the questions that are being asked. And this is where the Agile Data Warehouse Design book comes in. Here are 4 examples of business questions. So I'm trying to illustrate these 2 sides. We have a finance team that is curious about how much revenue is coming in online and from what products. We have a marketing team that's interested in which channels and platforms are converting and which aren't. Product team that's interested in how many pages does the average customer look at before they buy. And then the operations team that is interested in when are orders coming in and for what geographies. So the events that we saw before, there were those 4 events, and sure, they can occur in a sequence, but they can also occur in some cyclical ways. Somebody can check out multiple products. They can go to a product, but not add it to the cart. They can add multiple things to the cart, and then ultimately they can check out. So we're starting to see that there's some complicated, somewhat linear, but not fully non-cyclical relationships between these events. Now we can start seeing some questions on the other side of it. And these questions are starting to interact with either one or multiple events. These questions, and I'm going to get to it a little bit in terms of how it relates to the book, start to bring us more information about how the business and the business users are actually going to interact with data. So how much revenue is coming in online and from what products? Okay, so there I am thinking about what product it is, and then there needs to be that checkout. Okay, that's not so complicated. Which channels and platforms are converting and which aren't? Conversion. Okay, so converting between what and what? Between an X and a Y. That's definitely going to start thinking about multiple events and how those events would be related. All of these questions, really what I'm trying to drive out here is that we had 4 events, we have 4 questions, and it's not just one-to-one. You're not just going to have this event leads to this table, and then you can answer your questions. You're starting to get into the realm of how can I transform this data? How can I model this data to allow me to answer one of these questions, 2 of these questions, perhaps all 4 of these questions? This process, this kind of this whiteboarding process, in fact, whiteboarding is the first step of the BEAM process, the business event analysis modeling process that's recommended in the Agile Data Warehouse Design book, is the first step of many steps that can help push you towards designing a Kimball star schema dimensional modeling data model for your business. The whiteboarding step is when you interact with your business stakeholders to whiteboard questions. You really want to put it in their language, and you want them to tell you what type of questions they're asking, and what type of language they're using in those questions. You want to hear if they say revenue, if they say recognized revenue. You want to hear if they call it a channel, or if they call it a medium or a platform or whatever it is. And you want to hear the way that they start describing it. These questions are your whiteboarding, and then they lead you to another Agile Data Warehouse tool. And I'm just going to go through a few of these just because we don't have a ton of time. They lead you to the BEAM canvas. So a BEAM canvas is scoped to one business process, and it's helping push us from what those questions were to something that starts to resemble a star schema. And a star schema is that pivotal, or one of the pivotal ideas of Kimball dimensional modeling. We start seeing those questions, and we can start pulling out some of these 7 Ws, as they're called in the Agile Data Warehouse book. In these 7 Ws, we can start seeing some information in here, such as the quantitative bits of information. Just to flip back, I was talking about revenue. I was talking about conversions. I was talking about, number of pages is perhaps a little bit different. And then count of orders. When are orders coming in? Those bits of information are going to land there in the center, the how many bits of information. Surrounding that, there's going to start to be some of the dimensional information. We have our who, our customer. We have our what, our product. How, you can think of the channel as kind of like a how. How did they get to the website? Was it an organic channel? Was it a paid channel? You can start associating information to different dimensions around the table. When is a bit of a unique one. I'm not going to dig into that one too much, just because the when is really directly tied to the measurements. When is often going to be, when did they click on something? When did they land on the page? When did they check out? When did they do these various actions? Those are really going to be tied to the quantitative bits of information, but you can start to see how it's starting to develop. Lots of information, quantitative information is landing in the center. Lots of qualitative descriptive information is surrounding it in the nodes around, in the points of the star that surround the center of our beam canvas. So we have a lot of information there. And before diving into exactly how we're going to construct one of these tables, and I'm kind of glossing over the dimensions just because we could dig into each one of those dimensions, and I'm just focusing on the fact, just focusing on the business process itself, I want to bring us back to some Kimball terminology. And what I'm trying to do is kind of strike the right balance between the process and then some of the theory. It's just a cursory overview of this. If you want to learn more, I really recommend checking out the books. Beam is probably the Agile Data Warehouse Design book is the one that I would buy first, and then some of the other ones I would buy after that. But let's learn a little bit about this theory. What are different fact types? So we started collecting information about what we would need to be able to do. Now we need to know about a few of these techniques, a few of the tools that Kimball gives us to do that. We have 4 different fact types, and there's more than 4, but these are 4 of the most common that can help us accomplish various types of analysis. First one is our transaction fact. A transaction fact is really one of those 4 items that we saw at the beginning. It is one table for a single step within a process with 1 row per event. What that means is you would have one table for just adding items to your cart, for adding a product to your cart. You would have another table for checking out your cart. You would have another table for visiting a page, another table for clicking on a button. You would have 4 separate tables for our 4 steps, and each one of those would be really simple to use. There would not be very much ambiguity. There's really no transformation, but it's going to make a lot of those multi-step questions really hard to answer. How are you going to answer a question about conversion? Transactional fact is going to be great if it's a relatively simple thing that you're trying to analyze. You're kind of taking the Occam's razor approach of saying, how can I make this as simple as possible to accomplish this goal? A transaction fact has that benefit. It's simple, it gets the job done if it's just related to one event. But we can see that it's often not going to be sufficient. If it's not sufficient, we have a few other ways of getting there. An accumulating snapshot fact is another very common approach. It's another super common fact type. It's one table for one process with 1 row per instance with details of every step. So instead of this being 1 row per event, it's now 1 row per session. So now it's 1 row for a session, and now you have to be opinionated about how you construct that session. I can have a first page viewed at, I can have a last page viewed at, or most recent page viewed at. I can have a count of pages viewed. I can have a first product viewed, a last product viewed, a second product, an nth product. There's all of these different things that you can do. You can start seeing how it's opinionated. Think of this as horizontally joining information together. This is great for calculating durations. I want to know how long it took between the first page and when they checked out. I want to know the ratio of this to that. You can start doing it, but now you're being really opinionated about the way that you've constructed it. There's some data loss there. You don't have the same granularity as the transactional fact, but you've made it so much easier to calculate certain dimensions. A consolidated fact is another idea of joining data together, but it's a union. It's a vertical join of data. So it's one table for all steps of a process with 1 row per event. This is really common among product analytics. And I'm just going to talk about this briefly just because it's not a super high fit for our use case. Product analytics will join things in that vertical way. We'll union them together, and we'll think about, okay, how much time elapsed between this thing and that thing? How much time elapsed between these 2 events? If I'm looking at these events, I now, instead of just having 1 record for a session, I have every single breadcrumb. I can see that they saw this page and that page and then went to this product. I can see that they added a product and then removed it. I can see that finally they checked out. If I wanted to properly understand which pages they saw and for how long, a consolidated fact might be a better way of looking at it. If you've ever seen some of those funnel visualizations, kind of like a bar chart style visualization, a consolidated fact table structure is a good way of accomplishing that, because then you can have bars that are the height of number of events, number of distinct customers, number of distinct products. There's a lot of different options there. Okay, last one briefly, periodic snapshot fact. This one is almost always useful. It's an opinionated way of rolling something up to a period. It's one table for a variety of processes with one row per period. So a daily record or a weekly record or a monthly record. However, really similar to accumulating snapshot facts, but even more so, there's a lot of data loss that you get in exchange for being able to standardize. Here, you might have monthly session metrics. Monthly session metrics is a really performant way for you to pre-aggregate the table for your end users so they don't have to hit your database and run an expensive query. Even with a system like BigQuery, you may want to pre-aggregate it so that they don't have to scan the data at query time. But this is a way of doing it that is pre-aggregated fundamentally. So it's going to be opinionated. This is a great way for minimizing the cost of query time. This is a great way of standardizing certain metrics and saying, this is how it needs to be calculated. But periodic snapshot facts are pretty coarse. You don't have a way of diving into them and seeing anything further. Okay, so that's a bit of the theory. We saw our beam canvas before. We have some of our theory. Now let's bring it all together. So we can bring it together across this y-axis there. You can see how those 4 events have led us to, just as an example, 7 different fact types. Across the X, not really talking about that too much today, those are some examples of dimensions, and we can start seeing how our dimensions and facts would relate. Dimensions, we really want them to be reusable by design. Our business process here, we can see those 4 transactional facts, just as we saw them originally. We can see an accumulating snapshot fact for sessions that wraps up those 4 things. Also see a consolidated fact for session events, and then just one example of a periodic snapshot fact for daily session metrics. So we've gone through a lot of things, but now what I want to bring it back to is just thinking about which of these is going to help us answer our questions best. So when we look at these, we can start thinking, okay, an accumulating snapshot, it's going to be able to answer certain questions better because it traverses all of these 4 transactional facts. Consolidated fact, once again, a bit more product oriented. Periodic snapshot fact, it's going to perhaps be a good fit for everything, but with some of that data loss. So let's go through them one by one. Which fact types are most appropriate for each question? So finance, how much revenue is coming in online and from what products? So one of the nuances here that I was kind of hinting at the beginning is just associating revenue. So it has been checked out with that product. There's some manipulation that you may need to do. The checkout is not necessarily at the grain of the product. You may have to have kind of a fan out of that table, but fundamentally, this is one measurement. It's really just that checkout. The transactional fact is going to be a pretty good fit for this. If not, an accumulating snapshot fact could work as well, or a periodic snapshot fact. Periodic snapshot fact is going to work pretty well for most of these. Marketing, which channels and platforms are converting and which aren't. This one, hopefully you'll be able to see now that we've kind of covered a few of the basics before this. The transactional fact is not going to be appropriate. It's either going to be a transactional fact about the first part of the conversion or the second part of the conversion. This means that an accumulating snapshot fact or a periodic snapshot fact is going to be best. Accumulating snapshot fact will be nice and granular. It's going to be at the level of the session, or a periodic snapshot fact would be able to tell you the day's worth of conversion. What was today's conversion compared to yesterday? Next up, for product, how many pages does the average customer look at before buying? This one, it's a bit more unique. So our accumulating snapshot fact, that could also work out well, but a consolidated fact could be interesting if we wanted to be able to see all of these different pages that somebody had viewed. So an accumulating snapshot fact, perhaps you could see the number. You could see that somebody had viewed 10 pages. But what if I wanted to see what those 10 pages were and see them in order? A consolidated fact is probably going to be a better way for you to see that information, because if you start thinking about kind of like an amplitude, a mixed panel, more of those product-oriented BI tools, you'll be able to start looking at those events individually and start being able to see the exact trajectory that somebody went through. And then our last example, which kind of brings us back to something that's a little bit simpler, when are orders coming in and for what geos? So this one's nice and simple, kind of brings us back to that transactional fact. It has come in for a customer, and that customer is in a specific geography. If you can get away with a transactional fact, and I just kind of wanted to emphasize this part, if you can get away with a transactional fact, sometimes that's a good data model. However, if you can start building up meaning into something like an accumulating snapshot fact, despite it being more complex, perhaps you can answer more questions with it. Lastly, periodic snapshot fact. It's almost always a good fit, but it's the data loss that you're concerned about. You would be able to know, okay, when are orders coming in and from what geos? You would be able to know that at a daily level. But if you wanted to zoom into the hourly level, you're going to hit the edge of that grain, and you're not going to be able to look into it any further. So given that, this would help us know that perhaps starting with an accumulating snapshot fact and then potentially a consolidated fact or a periodic snapshot fact would be a good idea. If we go, oh yeah, let me just force my way back to the event matrix. This event matrix too, I forgot to mention, that is another one of the Beam resources within the Agile Data Warehouse Design book. This is a resource that ultimately you'll get to at the end of the examples of transactional facts and a few of the examples of dimensions. From here, what we would be able to do is prioritize and say, let's add another column beside fact type that says, what is the priority? And then for the dimensions as well, if this was a brand new data model and you were going about implementing these, you could see that perhaps it should be the user and then the platform and then the session. And then once you've created those first three tables, then you can think about building out the product dimension, the channel dimension, maybe a consolidated fact. As you add more business processes, your y-axis is going to get longer. We're talking about an order checkout flow. You'll be able to add other flows as well. Your dimensions, especially as you go through a more comprehensive whiteboarding process, are going to start covering more and more business processes, more and more facts. Let me get back to my conclusion. And that would bring us to our data model. So that brings you to the first artifact of your data model, an event matrix really kind of being one of those strong recommendations for something that starts showing you what your data model might look like without having to go through all of the trial and error of creating this table, seeing if it works, seeing if it doesn't work. I've only gone through kind of one main example. I've only really been talking about the facts, really talking about kind of the center of the star schema. We didn't get to talk much about conforming dimensions or any of the complexity that's built into that. But the key thing here is by building out these facts and building them out in a way that is meant to respond to multiple questions, it now opens up the door to a variety of different use cases. Those red nodes that we saw at the beginning, those are going to be unlocked now. Business intelligence, super common use case. This is just doing your reporting. This is doing the reporting on top of that data. Machine learning is also going to be possible. A lot of this data is great for feature engineering and for kind of creating more of these denormalized testing and training sets. Reverse ETL, this is a bit of a funny term for sending data back to source systems. So you've enriched your user. Now let's send it back to our CRM, or now let's send it back to an ad platform so that we know that that conversion had occurred. There's a lot of data use cases, data sharing, data applications. If you want to use this data to power some other sort of decision-making or system, now that's going to be possible. Last thing that I wanted to mention in here, and I think, yeah, especially kind of hearing a bit about some people's backgrounds, other skills to learn. You know, analytics engineering and DBT is a really interesting domain. This, we see a lot of people coming into it from the analytics side of things. So analytics analysts, basically, that want to upskill and learn more software best practices, learn a little bit more about what goes on under the hood in the database. That's a really interesting space where analytics engineering is starting to be populated from that side. And it's also being populated from the other side. A lot of people coming with software backgrounds or data engineering backgrounds and wanting to get a little bit closer to the business user. RBAC and access control models, this is, especially when I'm speaking to analytics engineers, this is something that I always recommend learning a little bit more about. This should be fundamental when you're designing your data model. And then lastly, database or data warehouse optimization, especially at large scales. I started hinting at it a little bit with some of those facts. It's going to be really important to the way that you design your structure and the way that you think about, okay, yeah, periodic snapshots have data loss and you're not going to be able to zoom in as much. But if you start partitioning your data and have massive data volumes, periodic snapshot facts, especially for some of those older partitions, are probably going to be much more of the cost-friendly way to go. Okay, just over 25 minutes, not too bad for time. I think we should have some time for questions. Thank you very much.
Thank you. Who wants to start first? This felt like a school. Thank you.
You know, I don't have a question exactly, but I just wanted to mention I fully endorse literally everything you said, because you basically just described a system that I was working on at my last job for quite a few years, even down to those like classic 4 event types that you mentioned there. Those became kind of my my data Bible when I was working there, because they were the 4 event types that powered our entire business. And it's exactly as you said, like you get your data in the data warehouse like that, and then you can do pretty much anything with it.
Yeah, yeah, definitely. And like we hear that very commonly where sometimes they have a bit of an intuitive structure. It's just nice to hear that there's a name to it. And then once you hear there's a name, once you hear that there's a bit more theory to it, you
Mhm.
can refer to the text and you can leverage the
Yeah,
text. And you can, yeah,
your names, do those names come from the books there? I wrote some names down here. One was transaction fact, accumulating snapshot fact.
yeah,
Is that from those books? So I
yeah,
remember struggling to explain those to my coworkers, because yeah, we literally had those tables. We were basically like storing the data in its very raw form and then creating like aggregated versions of it. At first we were doing it ourselves, and then as the years went by, we started using Looker, which had materialized views. So the business people in our organization could just do that themselves without having to have us data engineers do it for them. It's amazing like how much serverless technology has cropped up over the years too, to like make this easier. Anyways, my point is, thanks for putting a name to all these things for me.
yeah, of course, of course. And definitely check out the Kimball book. There's also there's more and more online resources that are related to Kimball modeling and dimensional modeling. If you need kind of those quick, if you're looking for what's the difference between slowly changing dimension type 0, 1, 2, all of that's online now. If you're looking kind of Kimball dimensional modeling SDD type 0 or something like that, there's those definitions and those links that are available. There's facts. There's a good set of resources online. The book is always going to be a bit deeper and more comprehensive, but check out both.
And I would add that Kimball is, if you're new to data engineering, Kimball gives you like the context, the theory, and then some base examples, so you can walk your way through, and then use a lot of the online tools to really kind of get the details of certain specific things, or maybe exercise on how to become more familiar with an aspect of doing any of those data engineering type work. Yeah.
Yeah, and there's some tools like Looker by design is really optimized for a star schema and for a dimensional model. There's also a lot of tools, and like even DBT with their recent semantic layer. DBT is a SQL framework. There's also Dataform, which is another SQL framework that's more kind of a BigQuery exclusive. But they're both looking at this idea of how can you model data in a more modular way and use some programmatic elements. But DBT has a recent semantic layer that they've released, which is kind of an integration to connect your modeling layer with BI tools. And the idea there is to say, okay, this is a great starting point, but then we know that people want to make pivot tables. And then we know that people want to do these types of analysis and these types of calculations. There's lots of extension there, but it's all kind of coming back to these ideas of this way that they started structuring data in the 90s, in the early 90s, is fundamentally a great and kind of like a really nice and pure way of structuring a lot of these facts. It's super useful for being able to zoom in on data.
We still have a couple of minutes for Q&A. Eric, do you want to ask anything? Because the first, when you spoke originally, it wasn't recorded. Any other questions? Go ahead. Yeah.
Yeah. So first of all, fantastic presentation, and I'm just curious about the architecture that you showed at the beginning. I know your point was not architecture, right? Obviously, it's data modeling, but curious if you were kind of deliberately simplifying the middle, just to say, look, don't worry about how things get from A to Z. Let's just focus on the modeling, or if you're kind of treating this sort of single warehouse with DBT layer transformation happening within it as the modern best of breed, rather than saying source to data lake and then data lake to data warehouse and all this being transformed by Beam or something like that. So just you're curious about that.
Great question, and it's totally going to depend on the data source and the. So more to your first point there, Ian, it's a simplification, and it's meant to kind of simplify across a lot of different things. A relatively simple architecture works okay with third-party data. So really just thinking about kind of dumping data into a data lake and having a warehouse directly on top of it and kind of doing all of that transformation in warehouse. If you're using other, especially higher volume data systems, if you're working with Beam, if you're working with Kafka, if you're working with Spark, there's a lot of other architectures, and especially this at a high level, people can identify with it if they're on Snowflake, if they're on BigQuery, if they're on transactional databases, if they're on a variety of systems. It's meant to be an oversimplification that makes some of these modern data stack concepts applicable, but it's definitely not a recommended architecture if you have a use case that warrants something like Spark. If you have low latency needs, if you have the need to have any of those systems to be doing some of the transformation in transit. But yeah, it's the idea of just trying to have a nice bow tie, saying here's data sources, here are data use cases. We know that a centralized data model really works for a lot of use cases, works for lots, but it doesn't work for all of them.
Good, that was really helpful. Thanks a bunch.
Any other questions? We have 3 more talks.
I have a question. So Jacob, speaking of data models, would you say that it's more important to come up with a data model when it comes to storing your data in the data warehouse, or should you think about your data model from the perspective of the users? Basically, like start from the back end versus start from the front end. I ask because this was a problem I never solved all those years I was working with data. I saw pros and cons of both.
Yeah, the book that I was referring to there, not these 3 books, but this this Agile Data Warehouse Design book is really advocating for the business first approach, and that's why fundamentally you want to start with that the whiteboarding session. This is in pursuit of a data model that represents the business, and hopefully in producing that is more durable to some of the data changes that may occur. If you migrate to a new system for tracking this, your business logic should remain the same, especially if you have some of these core concepts of revenue and of customers, et cetera. Business first is how a lot of success is seen in creating durable data models, but with a big star at the end of that.
And I would second what Jacob has said. Even for us, like we take the approach of doing business first, but recognizing that you often have a lot of technical people that are getting involved. We then kind of break the documentation in multiple layers. So there's the business friendly. So we'll have like business entity documents that are the terminology that the business utilize. And then we have documents that are more like the business attribute mapping, which is to say this particular business entity is actually found, and that's part of the documentation as part of like, master data management. This particular business entity is found in this table represented as, this column or this collection of columns joined together to form this particular thing. And then you can get even a level further underneath where you start looking at like all the infrastructure as code to represent modeling that takes place, in description of your source systems and how the data is like ingested, transformed, et cetera. So to Jacob's point, really it starts for the most part with the business, but you can go and document and bring it closer to your developer level representation and interpretation as the needs arises. But it definitely the focus is on the business first.
Perfect. So maybe this is a good opportunity to segue, to let Jacob sleep. He's 6 hours away from us, so it's very late. And then I will knock on your door again to ask for deep dive sometime in the future. This was awesome. Thank you. And is that okay? Can we move to the next presentation with Nadji from Infostrux? And it's going to be trends in data engineering consulting landscape. So it's similar to the OSI model, but we are now going from the application layer, Jacob, deeper down, one level down, until we hit the GCP and AWS in the last 2 talks. So Thank you, Jacob. And Nadji, please take it away and introduce yourself to the group.
Yeah, thank you, Jacob. So hopefully, let's do this. And okay, can everybody see my screen?
Yes.
Okay. All right, so let's get started. So yeah, so trust in the data engineering consulting landscape. As a quick intro, so my name is Nadji Bessa. I worked with Daniel a couple of companies ago in Infostrux. My background is I'm an electrical engineer by training. I was a developer for a couple of years, drifted into sysadmin, network admin way back. And it eventually found my way to DevOps practice, and I've worked as for many years as a, as a in a cloud practice. So I worked for many years as a cloud engineer, then became a cloud architect, and stayed in that space for quite a bit. As of recently, I've started a journey towards data. And my interest is primarily in data science, but as many of you will find out, and for example, there's been a lot of books that have come out. The most notable one as of late is Fundamentals of Data Engineering. It's hard to do data science without good data. And so I decided to make kind of the obligatory stop at data engineering. I'm currently an engineering manager at Infostrux. Infostrux is a consulting company in the data engineering space. And there I lead a team of data engineer, data architects doing a whole lot of data projects. And my talk today was really just to talk about some of the trends that we've seen. We're a 2-year-old company. We've seen quite a bit already. And judging by the interest of many of you in the room, there are lessons that I think are applicable for a lot of you if you decide to get into that space and do consulting yourself. Or if you're thinking about joining, organizations like ours that are doing data engineering projects. So feel free to ask questions as they come. We don't necessarily have to wait until the end of it. So while I'm going over some of those topics, if it strikes a chord, feel free to ask. I'm more than happy to dive into those details. So the approach that I'm going to take is look at lesson learned, if you will, for projects from what we encounter running projects, the data engineering practice and some of the lessons we've learned from that. I'm going to focus a little bit on DBT, but I'm quickly going to skip through. The slide deck is available. You're more than welcome to really go through the slide deck and extract, if you will, the lessons from our use of DBT. And as you learn or become more familiar with it, kind of refer back to it. And last but not least, a quick stay on the topic of tooling. Okay. So projects. I think for the most part, a lot of the work we've done in the last 2 years, there hasn't been any specific verticals. I think it is true that most organizations are trying to be data-driven. For the most part, it's really been all over the place. There hasn't been a single market on which we could say, this market versus this one is more focused on data engineering. What do our clients need? I think an interesting takeaway from the many projects that we've run is that when we approach data engineering at first, I must admit, even us as a practitioner, we're a bit worried of the fact that the data supports processes, knowledge in various segments, and how are we going to handle the variety of that data and what it means? But what we found very quickly is so long as there are subject matter experts like SMEs to interpret that information, as soon as you get to the data level, it's very common. It's very common problems. It's very common issues. The challenge is really to have the data SMEs available to try to interpret that information. But fundamentally, data is data across a lot of those organizations. And so long as you have, again, the presence of those SMEs, it makes a lot of those data projects approachable. So something to keep in mind as you venture into data, it is important to find a partner to help you make sense of it. But fundamentally, data is data, and a lot of the problems that are found in one organization tend to replicate themselves across a lot of the other silos as well. Visualization platform. We found Tableau to be like the overwhelming leader, followed by Power BI, Sigma, and Looker. And I just want to quick segue here. Jacob mentioned earlier that for example, Looker is geared towards like materialized views and things of that sort. A lot of those tools are a function of budget or some of the key features that each platform offers. We found that across again all the different silos of businesses that we've done, the businesses we work with, you'll find Tableau in organization you wouldn't expect to find Tableau. You'll find Power BI in organization where you wouldn't expect to find Power BI. There isn't again a typical silo where we can say this is what the predominant visualization platform. But overall, we found that those are the four that are used a lot in industry. Do you need to know all four of them? No, but being very familiar with one will help you understand the others and the concerns of your users with those platforms. So it's good to at least dabble with one. It helps you make all the other ones more approachable. From a strategic standpoint, what are the big challenges with data engineering projects? We quickly found that you cannot do good data projects without having at least good cloud or good DevOps. And as a result of it, initially our teams would be primarily data engineers, cloud architect, data architect. We started having kind of a resident DevOps resource within each team because we couldn't run away from having to set up pipelines, to set up automation. Often the data itself that we're trying to extract from different source systems is in a cloud infrastructure. So how do you get it out in the most efficient way? We quickly switched from being like purely data to being a mix of data and DevOps, DevSecOps, to be able to tackle those challenges. And so I think Jacob in his talk alluded to that a little bit. There is a bit of a bleed over where your DevSecOps resources on the team are going to learn enough data engineering to be dangerous and understand what the data guys are saying. Well, I need this, and that, like to understand what it means. At the same time, your data people are going to learn a bit of DevOps stuff to be able to explain cohesively what they need done from an architecture standpoint, from an automation standpoint. And so there's definitely no one can stay in their silo of knowledge. You have to bleed over to the surrounding areas of what you do to be able to gel well and interact well with others. So that's another finding from our 2 years in the business, so to speak. Operationally, the biggest challenge we found with a lot of data projects are basically how well stakeholders work together, making sure that they are at the table when important decisions are made, but also that their requirements and concerns are validated early in the process. So it's really important with like data projects to make sure everybody's at the table when it starts and while it takes place, to ensure that at the end, whatever product we come up with is really suitable for all. It'll be no surprise to anybody that has been in a cloud space for some time, but a lot of those projects, the tactical challenges that we encounter are mostly about getting access. I won't tell you enough of the assignments where weeks into it, we don't have access and how it delays a lot of things. So that's something to keep in mind. How to tackle that? My advice would be to anybody in that space, make sure that you identify the structure of the organization and how they tackle access, because often it's not just one team that's responsible of access. You may have a security team, you may have a cloud team, you may have several others that are partially responsible for the infrastructure they will needed access to. And so identifying early in the process who are in charge of the various aspects of the infrastructure is important. And starting to cultivate some relationship with them early on will go a long way to ensure that you have a proper access as you need. Notice that I think it's Gautam that has a question. Do you want to go ahead and read the question?
Yeah, hi. Sorry to interrupt. I was just wondering if you could full screen your slides. It's just a little difficult to see them.
Oh, I see. Give me a quick second. Let me do that.
Thank you so much.
It's okay now. Thank you.
Yeah, my apology. A quick second.
It's good, Nadji.
Okay, cool. Okay. On to data engineering. So so in terms of so those are some classification that we recommend when it comes to tackling how to classify your data. I think Jacob, for example, in his talk mentioned an approach in terms of the questions you ask, looking at the data that is available, and the types of data and how you want to approach classifying it. We take a slightly different approach. We tend to do the data engineering. We have a recommended, we have a reference architecture that we promote across many of our projects, and that architecture, to summarize it, we're very much a subscriber of star schema and Kimball's methodology, and so starting from the business and the business entities that it defined, we try then to organize data in such a way that it matches those business entities, and that would fall under a lot of the business domain area. But there's other ways to tackle how you want to slice the data. And you may want to consider, environment, so dev versus prod, depending on if your business, in the way that the processes are designed or how the data is going to be used, very much depends on the environment. Processing state for a lot of like e-commerce and applications like that. So this is a summary of the list that we find was useful in terms of how to approach data classification. And I just mentioned our reference architecture. So typically, we take the approach of having various layers. So someone asked a question earlier, the data warehouse that was in the middle of the diagram, what does it look like? Well, for us, we break it down in this way. So at the bottom right corner, you see the ingest layer that represents some aspects of the data warehouse, typically a database that is the sole purpose is to basically receive raw data from multiple sources. And so we would tend to have a database per source. So if you have an e-commerce website, you have some API data from some of your vendors. Every single source would have a raw database where the source data is ingested and arrives unchanged. And then we start to apply transformation to take that source data and clean it up. So the clean layer is where we remove any dedupe the data, remove any errors that we've detected in the data. We then go and normalize the data, so 1-to-many NF normalization, to basically have single facts, like single row data per transactions. and then an integrated layer where we start to produce that star schema where you have your fact tables and all the adjacent dimension tables that are related to it. And then we have also an analysis ready layer where essentially we do some aggregates or any other transformation to make it more BI ready, so to speak. I must preface all this by saying we choose Snowflake as a platform for our data warehousing. So a lot of those things, there's, for example, when it comes to ingestion, we favor an ELT model as opposed to an ETL, because on Snowflake, and that's applicable to other data cloud platforms as well, storage is very inexpensive. It makes sense to just ingest the data raw and then apply transformation, because you're always capable of going in and taking a larger segment of some of that raw data should you need it in a future time. So we much favor ELT versus ETL, and we go through those layers to make sure that as the transformations are applied, they're very dependent on the end result that is desired. And if there are other requirements for which we want to do different modeling, you can always go back to the source and build some new upstream models. So that's the overall architecture that we support. Oops, I went backward there. Whoops. Okay, and now on to DBT. So this part is extracted from an article that some of my colleagues have posted. I have the link there. Feel free to go look through. It details it a lot more. But essentially, DBT, so data build tool, we use it quite extensively. And one of the reasons for that is a lot of this came from cloud, where we use whether it was Terraform or other language to basically capture and document infrastructure. DBT very much serves that role as well, in that it allows to capture your modeling in a tool, and allows for someone else essentially to understand some of your business logic in a way that is very much SQL based, and therefore very approachable. So we use DBT to model the data, so like from raw to raw/ingest to clean, normalize, and integrate. And here what I'm retelling is some of the aspect of DBT configuration. So DBT leverages some YAML files to represent the structure of your databases. So this is one of the approach that we take. So we will build models following the structure, like ingest, clean, normalize, integrate, analyze, and egest. Egest being the layer where we take some data from the data warehouse and feeding it back into some kind of source system. We would have basically header blocks to define the databases, but also the materialization. And for at each layer, a series of select statements to basically take data from the prior layer upstream. So you'll notice that this particular statement at the bottom, there's a reference to customer, integrate customer, a table. So we can reference the layer down. So ingest is kind of the source. When you get to the clean layer, that is extracting from ingest and then applying some transformation. That's where we're able to do it. We basically select from the lower layer, apply the transformation that we need. That becomes this new layer, and then we can build on top of that in the next. So fundamentally, again, we have our sources, which are all the different systems from which data is extracted and ingested in raw format. We also have style guides as part of as in the way that we use DBT, and that is meant to basically standardize how things are written to make it easier for people to collaborate on a project. We also, as part of our DBT setup, build, have linters to ensure that the code follows the style guides. We put tests in place to ensure that we're able to validate models as they're being developed, and that also feeds into how we deploy CI pipelines to basically leverage the style guides, the linting, and some of the testing to ensure that we can reliably create a data pipeline that takes raw data, applies some transformation to produce then the business-friendly data warehouse data. And there are also elements of configuration to ensure that data is refreshed in the warehouse according to some of the data-specific requirements. So, for example, depending on the grain of the data in the warehouse and how it's used, we can automatically enforce the renewal of the data to ensure that what is there is accurate. So, if you rely on a report that that requires data to be refreshed twice a day, and and the source system can support it, we can ensure that this is automatically done, so you don't have to do that. And the way we use DBT is essentially, again, codified is in a repository. So we use version control to be able to manage the transformation work. So the workflow looks very much like how you would develop software, in the sense that you create a feature branch to track a particular model that you're developing. Once you've tested and deployed and are confident about your code, submit a PR to have it merged into the develop branch, and then from there, there's a whole gradation process where everything in develop can potentially find itself through main, passing through multiple other branches as your system requires, but definitely leveraging version control and software practice in that regard. And of course, as I mentioned, setting up CI/CD pipelines to deploy DBT. So I'm going to skip over those. They're very detail-specific things that I think makes more sense when you're more familiar. You're welcome to consult the slides afterward. And I want to get to tooling. So there, what did we find in terms of source systems and being able to ingest them into a Snowflake or a platform of choice? Fivetran, Airbyte, Matillion, SnapLogic, Supermetrics are among the popular tools. Again, as a practitioner, do you need to be familiar and an expert in all of them? No, but having a strong understanding of one will help you understand the others. And there are definitely similarities between some of those tools. And so it's a good idea to really pick one or two that you really specialize in, knowing that often you have projects where your ELT tool may differ, but having a solid understanding and familiarity with one platform will help you understand the others. When it comes to source system, we found that for the most part, in a lot of data warehousing projects that we manage, most of the data is still SQL based, but there is definitely a lot of unstructured data in the forms of JSON and in other formats that are there. A lot of the modern data cloud platforms provide you means to ingest for example, JSON, extract specific bits of it and flatten the data in tables. So it makes it really easy to get like unstructured or semi-structured data, and then still be able to query it through SQL-like structures, queries. And this is it. So thank you all for indulging me with this presentation. I'm taking questions if there are any at this point.
Thank you, Nadji. Who wants to go first? Awesome. Yeah, go.
All right, Nadji, I got a business question for you. I'm just super curious about who your main buyers are within an enterprise. Or do you guys get contacted by like the CTO first, or is it a business lead like the CMO or something like that who needs better analytics, and then the CTO gets pulled in? How does that work most commonly?
Most commonly, I would say it's the managers. They have to make decisions on. They need the data, and they call us in. And sometimes what happens is, as we deal with one department or one group, adjacent groups go, "Hey, we would want the same thing." And then it goes up to the CTO that goes, "Well, it seems there's two or three groups that want this. Can we maybe structure this and make it part of some bigger strategy or like data related strategy?" But often it's the managers that reach out and with whom we get started with a lot of those projects.
And by managers, you mean the business managers? So it'd be like a marketing manager or a
Exactly.
Okay,
Yeah.
okay, that's cool.
Yeah.
Thank you.
Yeah, welcome. Any other questions?
About visualization platforms. So you find Tableau more often being used than other ones. Okay.
Again, there's the Tableau like on-prem versus the cloud edition. Same with Power BI. I think when we approached this like 2 years ago, we thought, do everybody need to be Tableau and Power BI certified? No, you really need to be comfortable with one, and then depending on a project. So typically within a team, there are, I have my Tableau expert, my Power BI expert, but they're not all learning from the other tool. On occasion, you may be drawn in to work on something like in Power BI and you're a Tableau person, but the concepts are very similar. So once you're comfortable using one visualization tool, it's much easier to understand and work with the other. The key thing is to really get started and understand and be familiar with one. That makes it a lot easier to approach the others.
I see. We have a question. Cheryl has a question. What is the difference and advantage of those source system tools over common IDs like VS Code? Cheryl, you can speak up. Like you don't have to chat.
So typically, for example, DBT offers the DBT Core, which is an open source, as in free speech and free beer, open source project. So you could download the tool, set it up on your machine, and use it. So when we use DBT Core, we use visual. Most of us will use like VS Code or some other IDE to use it. As I mentioned, the code itself is in a repository, so we treat DBT as if it was like a software development project, essentially. So use the flavor of the IDE that you prefer. Most of us would use VS Code. DBT also offers DBT Cloud, where they provide a UI. And I would say if you're not a Linux command line developer kind of person, maybe start with DBT Cloud. Clean interface, very easy integration with like GitHub or any other repository system, and really learn DBT that way, get familiar with it, and then maybe venture into DBT Core once you are a bit more familiar, just so that you're not kind of chasing two things at the same time, like the challenge of getting the tool to work and then trying to learn modeling. So maybe start with the modeling with dbt Cloud, and when you're comfortable, maybe venture out and using dbt Core to maybe extend your knowledge into understanding a bit better some of the foundational pieces that allow dbt to run.
Any other questions? Or if not, John, do you have any questions? I keep mentioning Nadji and our friends from Trainibus now Infostrux often. No. So thank you so much. Like it's a similar, like maybe I can share my experience. So this is because there are people who lost jobs who are looking to start their career in the DataOps world, in the modern data stack. So when we began the meetup, Eric was here. He was talking about this agency approach for the small shops. There are like quick wins that you can get with finished connectors, like by company like Fivetran, for instance. I like using them because they come up with data models, so I don't have to think about the data source. And if I'm lucky, it's transactional information. I just set up the view on top of that, so it becomes one big table. So that's a quick way without too many transformation layers for somebody starting into this area from the entry level kind of, not big boys club, but one-man consulting shop. Like,
I actually wrote an article in Medium. Daniel, I'll try to find it and send it to you, so maybe you can post this.
please.
I was exploring the whole idea that, if let's say you've been a cloud engineer like myself for many years, you want to retool into data, like what do you do? There's so many things to consider. There's so many technologies. I will boil it down to you need some foundational knowledge. And so the Kimball book is a good one to start because it equips you with the terminology and concept around data engineering. Next, I would say try to find a mentor. Not because that mentor is going to teach you everything there is to about data engineering, but it's a resource with whom you can interact to say, hey, I'm doing this. What do you think? And it can give you quick direction. Oh, good idea to pursue this. Not a good idea to pursue that, and then help you through your journey. When it comes to tooling, there are tools or pieces of knowledge that are everlasting versus the latest fabulous, more popular thing that tomorrow will not be in fashion. And it's really important to try and identify, is this core knowledge? For example, the modeling is an important concept. Modeling will be expressed in dbt, will be expressed in other tools. So understanding the concept of modeling is important, but then learning dbt is just a tool. Maybe 3-5 years down the road, there'll be a better tool to do modeling, at which point maybe you'll drop dbt and do something else. But it's really understanding the concept of modeling that is core. The tool will follow, and maybe you'll use something else to do it. So those are kind of like the three core ideas. In the article that I'll send you, Daniel, I kind of detail this in more depth. But those are the fundamental pieces. So I would invite many of you, if you're considering going from, let's say, from a cloud or software engineering into data engineering or data science, approach it from those three pillars of considerations, and the rest is just time and effort, like anything else.
Mm-hmm. Thank you so much, Nadji. Lots of people will find this talk very useful. So, and they can always apply it for job in your company or Montreal Analytics and get training and a job.
That's right. So I posted a link for some of the positions that we're advertising for. So please, check them out. Check me on LinkedIn. Send me, if you have any further questions beyond this tonight's session.
Thank you. So I think we are a little bit over time, but this was fun. Now we are moving into more traditional serverless meetups, looking under the hood. And the next talk will be by Hugo from Google about data engineering and serverless pipelines. Hugo, are you with us, or you are? Yeah.
I'm here.
So sorry, like you waited, but
no, it's fine.
We can stay longer.
I'm just wondering why you call us traditional. Come on, man. Like, did you just call
Daniel so
like cloud providers like traditional?
No, serverless user group. So like people are wondering why we have data talks, and that's why I explained at the introduction. I believe serverless problem technically has been solved by the cloud vendors, not even DigitalOcean.
Yeah, that's fine.
Yeah, well, and maybe as an introduction to the second half, we should just sort of give the opposing view, and that's that Daniel likes to say that compute is a solved problem, and that may be true, that functions as a service, yeah, they work well and they're a solved problem. But the compute landscape is a lot more than that, obviously. If you know, to build good architecture of a serverless system that involves all the pieces, not just the compute, and manage your infrastructure as code through a pipeline, just like you do your code, and to have your developers embrace infrastructure as code as part of their development lifecycle. There's a lot going on there still, and there's a lot to do. So I think these next two talks are going to address more of the quote unquote traditional serverless. Looking forward to it.
Thank you.
Yeah, okay. So I'm going to share my screen very briefly. And I think I'm sharing my entire screen, like everything. Okay.
Yes, yes.
Now, what I intend to do here is a couple of things, right? First of all, take a step back and walk us through what building typical software delivery pipelines, but specifically natively to Google Cloud, right? Pardon me, I should have introduced myself. So I'm Hugo. I'm a senior technical architect, and I work for Google. I work in a team called Application Modernization. It's a specialized group of engineers, pretty much, who help companies, customers modernize their application and build and deploy on GCP. I've been with Google for about 2 years now. Prior to Google, I worked with Thomson Reuters as one of the engineering leaders in SRE and DevOps. Did quite a number of transformation around some of the traditional, unquote, the real traditional stuff they had to cloud providers. Very quickly, I don't really have slides, so just I'm going to present directly from my Medium link. Now, this is really what I wanted to chat about, but before we get into this, maybe just a quick show of hands. How many of us have, like, I know a couple of people have said this, but how many people here have like some DevOps kind of knowledge, some infrastructure as code kind of knowledge? Awesome. Awesome. Okay. So we have a lot of folks here. Oh, size. Yep, I can do that. Is this, tell me when it's good. Or I can just increase this and, is it good? Nope, yes. Better?
Yep.
Okay. And secondly, how many people here have done any kind of CI/CD with any cloud provider? And I mean native CI/CD, right? Not just Jenkins. I mean native to the cloud provider. So like cloud build, cloud deploy, any of that? Okay. Thanks. Thanks. Okay. Now, great. So this is what I'm going to do. I'm just going to do a quick run through of what my pipeline is going to be based upon, right? And by run through, I mean the architecture and the infrastructure layer that the pipeline that I'm going to deploy is built on. Now, one of the things that I know is very common to DevOps engineers or platform engineers is really the concept of GitOps. Prior to GitOps, there used to be, not really prior, but before the GitOps terminology became very, very popular, I think what we used to really hear was the build once, deploy any, where it is the same binary that you build from a dev environment that gets promoted all the way to production. And in that scenario, you're not necessarily merging to branch and triggering deployment process through multiple branch. It was just a single branch or maybe a single master with multiple feature branches, and you merge that feature branch and it deploys to all the way to production through something we call a promotion process. Now, the concept of GitOps, and I'm saying this is pretty much very foundational, but the concept of GitOps is pretty much where Git is the central source of truth. Now, in that context, what pretty much happens is everything around your infrastructure, all the way to your application, is stored in Git. But this time you have like a layered approach where you can structure your Git repository as either a dev, a UAT, or prod, or you can use tags to do that separation and have a single branch. Now, in this session, which I hope to make more practical and more demo/POC oriented. Oh my God, my kids are at it. Give me a sec. My bad. That
No
had
problem.
to. No, that had to happen to at least
If
one
you can
person.
increase the font, I hear in the chat that people still cannot see. A little bit more.
That's weird. Is this big enough?
Cheryl?
Sorry. Once I switch, I can't see. Is this good?
Yes to me. Yes. Not big enough. Oh my God.
Really?
That's not what I'm saying. I'm reading the chat.
That's weird. Is it good?
Cheryl, are you on a mobile phone?
I think it's legible. Yeah. If you hide the, you can do a view where you hide all the faces and chat, and then you'll see it bigger.
Okay.
Hmm.
Is that for me or?
Sorry,
is
no,
it-
not you. I meant Cherry.
Oh, okay.
Cherry can make it bigger by hiding the other people.
Oh, okay.
What you're doing, I think, is about as good as you can do.
Okay. I mean, we're at what now? We're at. Okay. Anyways, so let's keep going. So this is what we have. If you're not familiar with GCP, I'll quickly do like just a high level overview here. I know we don't have a lot of time, so I need to get deep into the weeds, but GCP allows you to have a single organization. So say, for example, I have testcompany.com. I can have a single organization, and within that organization profile, I can have multiple projects. Multiple projects, when you think about projects, think about like wrappers where you can create isolated resources that do not necessarily talk to one another when you create these resources, except you clearly define policies that tell them to talk to each other. Now, that's really what's happening here. What I've done here is I have Git as my central source of truth, and I have multiple branches, dev, UAT, prod. I have a single project, which I call my delivery project. And within that delivery project, I have a service account that interacts with a dev project, a UAT project, and a prod project. And the delivery project is where I drive everything around Terraform. But that driven process creates resources within the individual projects, dev, UAT, prod. I hope that's clear. Now, just a quick run through of what that looks like is here. I'm going to try to enlarge this again. Now, so here's my Git repository, and here I have dev cluster, prod cluster, and UAT cluster. Now, what I have on the other side, sorry, I'm going to switch screens here. What I have here is, and when you see that here, you can see the delivery pipeline project. Within the delivery, sorry, I have a delivery pipeline project, and I have the individual projects. You go dev, you go prod, and the UAT. Now, if that makes sense, let's walk through the Git repository. Now, one of the reasons I'm maintaining the master here is because you can actually leverage an environments folder where you can say, for example, I don't want to have multiple Git repositories, so I don't want to go the GitOps approach. I don't want to have multiple repositories because that always introduces some layer of management, especially when you start to go into the application side of things where your number of microservices can quickly scale. You want to be able to think about your Git repositories differently. But here, because we just have 3 environments, it does make sense that we are able to have individual repositories, right? But in scenarios where you don't have individual repositories, you can actually have a single folder and then link that to Cloud. So you can link that to Cloud Build and tell Cloud Build to build at a folder level. Now, but this is not the approach that I'm taking. So I'm not using the approach where I'm using the folders. I'm using an approach where I'm using the directories, multiple Git repositories. And here I have different branches. Now let me do a quick run through of what this pretty much looks like, because these are already pre-built clusters. So if I navigate to Kubernetes, you can actually see that in each of my projects, I have a dev cluster. In my prod, I have a prod cluster running. And in my UAT, I have a UAT cluster running. But how did that all get built? That all got built by me integrating these individual repositories to what we call Cloud Build. And when you think about Cloud Build, think about your typical CI tool, something like a Jenkins. But in this case, it's a CI tool that is inside, as provisioned and managed by Google. Now, Cloud Build, the underlying architecture is pretty much container based, right? The storage layer is built upon Google's central storage mechanism, Colossus, but that's not about it. So what I want to show here is really the trigger side of things, right? In the triggers, you pretty much have the individual repositories being mapped. So here I have my dev cluster, and that is mapped here. So let me go back to this. So what I've done here, if you recall, is I said I have mapped what is called a Cloud Build trigger to my individual branches. So here I have dev being mapped to my dev branch, and that is being defined here. I'm defining that I'm mapping this trigger to dev. On the other side is same thing follows for UAT and prod. So in the UAT trigger here, I'm mapping this to a UAT cluster. So the concept really is that this is using the GitOps mindset. If I want to interact directly with a folder, I can actually specify that here, but that's not what I'm doing. So that's pretty much it on the Cloud Build side of things. These clusters are already pre-built, but I think one thing to show is just really about the Terraform side of things. So if I go to GK cluster, go to environments and come here, I do have a couple of things, Terraform resources defined. The first thing I have is the backend. And here is really where you specify your Terraform state to be stored. So what I have in my scenario is my dev cluster has a Terraform state, my UAT cluster has a Terraform state, and that is all managed by backend, which is cloud storage. Cloud storage is a storage layer, is Google managed storage layer for objects. The other thing I have here is gk.tf. This is really where I'm defining what my GK cluster will look like. Here I'm using more of the regional cluster. And so I have I'm deploying a single region, but having multiple worker nodes across multiple availability zones in that region. This is not a Terraform talk, so I'm not going to deep dive into how to write Terraform templates. The other thing I have that is critical here is really where I'm specifying things around my variables, right? So my TF vars are pretty much defined here. I'm saying I want to deploy in my UAT project. I want to deploy in Central as a region, and I want to deploy as a cluster named UAT-cluster. And that's pretty much what I've done for dev, UAT, and prod, right? Now, like I said, all of these clusters are pre-built. And if you want to know how to replicate what I've done here, you can just, I can share this Medium page so you can walk through this. Any questions so far? No? Okay. Now, the next thing we want to get into once we have the clusters pre-built is really the deployment side of things. And this is what I wanted to chat about. Now, there is a very interesting architecture that was created by one of our engineers, one of our DevRel engineers. And that is Priyanka. I'm not sure most of you have heard about her, but she does a lot of talks. This is really what the cluster looks like. Sorry, the pipeline looks like. Number one, it has something called artifact management. And this is really where, when you think about artifacts registry, think about something like, what is it called? JFrog Artifactory. Or think about something like Nexus Sonatype, if you've worked on that environment before. But these are pretty much storage layers where you can store your Docker images, you can store binaries, your application binaries. Now, when you think about the continuous integration side of things, is really about the Cloud Build. like I said earlier on, Cloud Build it was initially Google's CI and CD tool. So we used to use Cloud Build for both the build side of things and the deployment side of things. But like I said earlier on, if you recall the processes around GitOps and a build one, deploy any, when you talk about deployments, one of the things you want to have being captured in your deployments is an ability to roll back, right? You also want to have that ability to promote across multiple environments. Now, Cloud Build does not really give you that functionality, and that's why Google introduced what we call Cloud Deploy. And so if you see here, CI happens within Cloud Build. Source code here, I'm going to use Git. From a CD standpoint, we do have something called Cloud Deploy. And like I said, Cloud Deploy was introduced because we wanted to create a tool that allows you not just to have that rollback capability. So say, for example, I deploy a 1.0 version to production, for example, or UAT, and I want to roll that back just by a click of a button, right? Cloud Build allows you to do that. Where you use something like, Cloud Deploy allows you to do that. When you use something like Cloud Build, you're not able to have that automatic rollback process. Now, I'm going to quickly jump into what this looks like. So this is the architecture. Again, I'm going to share this. I know we don't have a lot of time because I spent it pretty much having a dry throat, but I'm just going to switch to my environment here. Quickly, maybe before we go ahead, let me just walk you through what the Git repository looks like. First of all, I have an app manifest file. In my case, I'm going to be using Nginx as my microservice. So this can be anything, right? But here I'm defining my my Kubernetes YAML file, It is very weird. I was fine before this, and all of a sudden this is happening. Okay. Somebody had a question. What was that? Is there a link to the flow diagram tool? Yes, I can share that. In this article, I don't think so, but I can add that. Yeah, I can add that. It's a tool that was released by Google. I think it was released last year or last 2 years. I'm not sure, but yes, there is. I will add that to the I'll add that to the article. Okay. Now here I have my Kubernetes YAML defined. The other thing I have is pretty much a folder where I define my Docker file, and I have a ton of shell scripts that are requirements for to build my Docker image. I have a README. I'm very poor at README, so I think Matt can help me with that because he's great at documentation. But the next that I have here is really Cloud Build, and this is really where you start to get into the weeds of how to really configure Cloud Builds. Now, Cloud Build allows you to have the same concept as Jenkins, where you can actually have like multiple steps within a pipeline, within a Jenkins job. That's pretty much the same concept here. So you have you have steps, and then you have individual steps that define what you're trying to do. In my use case here with Nginx, I have Cloud Build. I have the build process, which is really where I'm building the Docker image. The next is really where I'm pushing the Docker image. Here I'm using GCR, and GCR is Google Container Registry. So when you think about that, think about Docker Hub. The next thing here is me registering my pipeline. So I'm trying to create a pipeline, and I'm defining that pipeline as an Nginx pipeline, which is the name I gave it here. I'm going to show you what the Cloud Build deploy YAML looks like. And in here, I'm defining the region where I wanted to create this pipeline. The last thing here is really just the release process, right? I'm defining the release name, Nginx pipeline. I'm defining the region here, and I'm defining the image I want to build. Sorry, the image I want to deploy. Pardon me. Now, Cloud Deploy leverages Scaffold. And so with scaffold, it's pretty much how Google handles the interaction, the visual layer of what's going on behind the scene in terms of the deployment flow. Now let's do a quick deployment so we can see what that looks like. Here I have my Git repository. I'm just going to navigate quickly to my CI/CD Nginx. That's pretty much what I showed earlier on. So what I'm going to do is I'm going to make changes to my app manifest. So I'm going to do CI/CD, CD app manifest. Pardon me. I'm going to VI this. Oops. And I'm just going to do a quick change to my Docker image. I'm going to change this to version 2. Save that. I'm doing a quick add. Git commit. Changing add version. Hold off the push because I want to make that change within Cloud Deploy. So I'm going to go to Cloud Build. Because if you recall from the steps I shared earlier on, Cloud Build is really where we're defining the steps, right? We're defining what needs to happen. The build, the tag, the push, all of that is being defined in Cloud Build, even the deploy process. Now, the deploy process is really the first deploy because every other deploy happens when you make changes directly to the application. In this case, that will be your Docker file or the binaries that are built through your Docker image. But in this case, I'm going to make a change because I changed that to 1.2. I want to deploy 1.2, so I'm just going to make changes here. Oh, sorry. I need to build and tag with 1.2. I think that's about it. Okay. Oops. I'm going to save this. And I will do git add. I should have shortcuts for this. Git commit. .v2. And I will do a git push. Now I'm going to switch over to Cloud Build, so you can see what's going on here. I'm going to switch to history. And you can see here that that's being built, right? If you click on that, you can actually visualize what's going on. So it's started the step 0, which is really the Docker build. It tries to build your Docker image with the tag that we specified here. And when it's done, it's going to push that to container registry, right? This is container registry. One of the things around security that Google has added to container registry, which has been around for a while, there are a couple of things. First of all, there's something called binary authorization. And binary authorization pretty much works in a way where you can actually sign your Docker images, so you can build security specifically around your deployment layer, right? So say, for example, I want to sign specific Docker images because I want to validate that we, as a company, were the ones who built these Docker image. That's actually very possible. So you can have something, you can implement binary authorization on your Docker image. The next thing that is very, very neat here is this scanning capability. So Google allows you to, container registry allows you to scan your Docker images constantly for vulnerabilities. And these vulnerabilities, once it finds any of these vulnerabilities, it actually publishes it and tells you what to do in terms of remediation. So I'm going to show you here, for example, I'm building Nginx here. So that's this. This was just pushed here. And you can see here that vulnerabilities is saying never scan. So I can actually enable the scanning process on these images. I haven't enabled that, but that can be turned on here. So that's me turning that on. Like I said, the security layer can actually be built also from a signing perspective where you sign the Docker image and the images are actually, that signing process is actually validated by your deployment engine. Now, I'm going to switch back to the cloud build trigger. And you can see here that it's successfully built and it successfully deployed that. Now, when I switch to cloud deploy, you can see what's going on here. So I have 3 layers. And if you remember this, when we shared the scaffold environment, sorry, the cloud build YAML, which was here. Maybe I should share that again. Let me just go back here. You can actually see here that we defined 3 environments. Okay, I don't think I talked about this, but quickly, we can actually see that we have 3 targets here. So the target is dev, UAT, and prod. And here I'm specifying each of my individual clusters, right? So I'm specifying that this is in project, you go dev, this is in US Central, this is also in US Central, and I think the other one is in US West. Now, so I have deploy, I have dev and UAT in Central, and I have prod in West. But I think what is very neat about this tool is really that ability for you to promote. So we've deployed Nginx, and we can validate that this actually works. So if I go to my dev cluster, that's here. Is that the right project? Sorry, I think it's this one. Oh, my bad. Kubernetes cluster. So if I validate here, I go to workloads, I can actually see that that has been deployed, right? And if I want to test that, I can actually go to service and ingress and actually just validate that that exists. Sorry, or that is functional, and that works here. Now, that is at the dev level. What happens at the UAT and prod level? So I can promote this build, and okay, I already promoted that build. So I can promote the build, the same binary. What is really happening is I'm promoting that binary from my dev environment to my UAT environment. And when that successfully, oh no, I think it's different. I'm just going to promote that. And all you need to do to promote is just click on that process, click on that tab, sorry, and click on promote. And it tells you the different releases, right? So it tells you that you have this release and then you have a different release number. So that tells you the kind of changes you're trying to make. If you go to manifest diff, you can actually validate what is changing from a manifest standpoint. And you can actually see that the release ID is completely different. And I'm going to promote this. And once I promote this, it deploys the new Docker image that we just built. Of course, the build and test phase happens within your dev before you promote to UAT. And once that promotion process is completed, what I've done in my scaffold environment is to add an authorization layer. So what I really have happening here is I do have a requirement for an approver to actually say, hey, I approve of this process. But again, like I said, right, there are a ton of things that you can build into this, right? You can build the binary authorization layer where you can say categorically, if I sign my Docker images with a specific key, that key needs to be available before it goes all the way to production. Just a way for you to manage security. And of course, you can have the scanning capability. Now I want to promote this. I'm going to click on promote, and you can see clearly here that the promotion is between the previous promotion process was from dev to UAT, and now it's going all the way to prod. You can also validate the manifest of diff. And once I click on the promote process, it then tells me to validate, right? So you can see here that the reviewer process has now been triggered, and I need to review what is happening. So of course, the review now allows you to validate the different release IDs and validate the changes that are being made. Now, once I'm done with that, I review that and approve. And it goes all the way to production. And you can validate what is happening by just going to your production project and validating what's happening at a cluster level. Let's see, that's done. Okay. Now, part of what intrigues me about Cloud Deploy is really that ability for you to visualize specific metrics that tie directly to your delivery pipeline, right? So things around deployment frequencies, things around deployment failure rates, right? This is really how DevOps is being measured right now. Well, not really DevOps, but this is how software delivery is really being measured beyond just the number of commits that you're making. Because if I want to measure a developer, one of the things I want to validate is how quickly is that deployment to that new feature being implemented, right? What's the deployment frequency, not just the code changes. I'm going to pause here. I think I'm pretty much done, but I just wanted to see if anyone has questions. I'm not sure how we're doing with time.
We'll be okay. 30 minutes, so that's 20, 30.
I have a few questions if you don't mind. So first, just a quick comment. I think that's a really cool tool. I stopped using GCP right before that tool got released, so I never got to benefit from that. At my company, we used to set up like GitOps tools, like Argo CD, and then if we wanted to promote things from one environment to the other, we had to literally like copy and paste from one YAML file to another, or merge a branch into another, and that was so error-prone and annoying. It's cool how you just clicked a button. My question is, can you like use this tool as one serverless tool with other tools you might be using or other clouds? Like I could even plug my own cloud here, DigitalOcean, right? Like can you deploy a DigitalOcean function or deploy a binary to a droplet or VMs using Cloud Deploy?
So I think the short answer to that is no. The target right now for Cloud Deploy are GKE, Google Kubernetes Engine, and Cloud Run. Yeah.
So I used to work as a data engineer using Google Cloud, and I used to butt heads with our SRE team because they had all these Kubernetes-centric processes. One of the processes that I couldn't really do was deploying to Dataflow in a nice automated way. Are you saying that right now, like Cloud Deploy can't help with that? I can't deploy a new version of my Dataflow pipeline or promote it?
Right now, it's not there. Yeah.
Got it.
I think that's in the roadmap. Yeah.
Though, right? Because if you can have a deployment step, which is a bash script, you can basically do anything you want with it. So you could send an event to the cloud,
exactly,
to kick off another process, and so on and so forth.
Exactly.
Actually, I'm familiar with Cloud Build and how I could just put a bash script in there. My point was I really liked the Cloud Deploy part there, where you were like, here's what we've got in dev. I'd like to click a button, have my supervisor approve this, and then it gets deployed to prod as well. It sounds like right now that is like GKE only, right?
Yeah, correct.
Got it.
Yeah,
cool.
Well, you can drive that with Cloud Build. Yeah.
Makes sense.
Yeah.
Cool.
Any questions? Sorry.
Anything in the chat? So, okay. I don't see anything in the chat. So, last chance.
There's a question. Oh, that's Matt. No. That's Matt. It's fine.
Mm-hmm.
Yeah.
This is awesome. Thank you so much.
I got my answer. I saw it right there.
And I got my answer because the question was Cloud Run. I as I mentioned, I don't use Kubernetes, but I love Cloud Run and was wondering if it can be used. So it can. Thank you. Awesome. So thank you. So we are down to the fourth closing presentation. Mike, thank you so much. Like you did it 2 years ago, you closed the 3-year birthday party. So thank you for doing it again and hanging with us all these years.
Yeah, no problem. My pleasure. Let me see if I can figure out the screen sharing situation here. Sorry, this is the first time using the browser to do this, so it's gonna ask me to Google Chrome's already there. Should be okay. Let's see what we can do here.
Yeah, the Google Meet can be picky sometimes about security and whatnot.
Yeah. All right. Let's see if Google Chrome might not have screen sharing permissions. All right. Sorry. Give me 1 second here. No, it definitely does. Try one more thing. Oh, sorry, Daniel. I'm not able to share my screen. Give me 1 more second. I wonder if I try this. Let me jump over to Safari.
Yeah. We did it before. It was Google.
Yeah, I've always had the most problems with the Meet.
Mm-hmm.
It always seems to be smoother on Zoom or Chime or any of the other ones.
I try Firefox sometimes if it doesn't work. Or if you want, I can project the slide and then you keep telling me next page, next page. You're mute.
Oh yeah, we don't hear you, Mike. Sorry.
Oh, sorry. I'm trying to join from Safari. Do you want to? Are you able to let me in there? So I was trying to get in.
Oh, is there a meeting room problem or a waiting room?
I don't know. Let everyone send message. I don't know if there is a problem. I'm letting everybody in. Can you? Like we are way below the capacity. It's 150 limit.
What was the technical problem you said you were having?
Just
There are
unable
two
to share.
problems.
So
can
my
try and
coworkers talked
join.
about a known issue, by the way. I just want to mention this. My coworkers talked about a known issue where if you're using Safari and Google Meet, you cannot share, I think it was a tab. You have to share your whole window, your whole screen, sorry. You can give that a shot. Or if that's not going to work for you, you might have to switch to a different browser.
Yeah, I'm having no luck with Chrome. So give me a second here. Try one more thing, Daniel, and then.
Oh, sorry, I said that wrong. It's not Safari. It's your operating system. It's if you're using a Mac with Google Meet, you cannot, no matter which browser you're using, you cannot share just a tab or a window. It has to be
Yes,
full screen.
Gotham is messaging that.
Okay.
Okay, admit. Auto admit. You're in.
All right. We'll try over here on Firefox. Screen 2.
Oh, we see you.
Yeah, we got something. Looks good.
I love these colors.
So you're just seeing
Orange.
like the desktop?
Flower.
Yeah.
Yeah.
Okay.
Drag the presentation onto that window or something? Or no?
Yeah, it's up there, but not showing. Geez, I think I'd be better at this. I'm gonna try one more thing. Window. PowerPoint. Is that showing anything?
Nope.
Nope.
Right. Let's try one more thing. Share. Entire screen. Screen 1.
And funny thing is, this is 4th time you're doing this. Like maybe twice it was real in person, and once it was virtual.
Yeah.
We never had problems.
So what are you seeing now?
I see 2 of you, 4 of you.
Yeah, we see the browser window with the Meet, the Google Meet tab. We can see your little pointer. I did see a pointer for a second.
Try it one more time. Nothing.
No.
Yeah, I've enabled sharing for it and everything else.
I'm sorry.
It's okay. The other problem, Daniel, I think, is I've got a hard stop at 5 o'clock here or 8 o'clock. So we
20
Might
minutes.
want to rain check this.
Oh, we can do that too if you want, or we can, yeah.
Yeah,
What does the group build? Phil?
It's okay. Apologies on this side for the difficulties. I don't know what the problem is, but I think we're tight on time. So maybe use the rest of the time for Q&A.
Okay. Okay.
Yeah, so if anyone has questions for any of the other speakers, well, I guess we lost, Jacob had to go.
Yeah, and Cyril as well. So we don't have any, but Nadji is doing similar things.
Yeah.
So you can help others, and you posted the Nadji link to your article, helping people move into the data space. That's very nice the way I was chatting here, because people have to pay mortgages, so why not offer the helping hand? Thank you for that. Matt, you go. Anybody?
I don't have any questions because I had my questions all answered already. I was jumping in and interrupting folks.
Yeah, and Hugo was rushing to finish. Now you have time. If there is anything else you want to say, you can add to a presentation. It was really nice. I never used Cloud Deploy.
Yeah, that was
no,
neat. I hadn't seen it either. I've used some of the similar things in the AWS world, but does the what was I thinking of while I was watching you? Oh yeah, does the cloud deploy if you're deploying infrastructure to a certain environment? As a part of that, you can do some integration tests or smoke tests as a part of that final launch or whatever for each of the like UAT or whatever as it goes there. Would that be like a final step you can put it? So you're doing all the deployment, and then there's maybe a few things that runs just to make sure that everything looks like it's working sanely.
Yeah, you can do that.
Yeah. And does it have a feature for like a canary kind of feature where you can deploy the new infrastructure that you've just launched to like 10% of your load balance and then cut back if it all, and then go forward if all the tests pass, or you don't normally do that?
So it's more of a progressive rollout right now. So it's not really like a canary, right? It's pretty much you're deploying everything to a specific environment, right?
Yeah.
Now what you can actually do is, in my case, I was using dev UAT prod, but then you can have a scenario where you can actually say, hey, I don't want to deploy to prod. I want to make this like a pre-prod. Now, it doesn't really allow you to do traffic splitting, because I think that's what you're referencing, right? Where you can actually split traffic between like different versions. That is something that I think you can architect that, but not necessarily with cloud builds. You might have to not necessarily with cloud deploy. You might need to rely on something like cloud build to make that possible. Yeah, because it really doesn't give you that traffic split capability. It actually makes you it's kind of a progressive sequential kind of deployment where it rolls out based on a promotion. Yeah,
makes sense.
But then we've also seen use cases where if your environment is one of those multi-production, multi-regional kind of environment, you can actually progressively deploy to your production environment. So I can say, I have a production environment in region A, for example. I want to deploy to that region. I want to validate what the experience of my users are on that production environment. And then if it's sufficient and successful, I can then progressively roll that out to other regions, right? So it's still going through the promotion process. The only difference here is that you can actually have like multiple production environments, and then you can roll back sequentially too.
Right. So if you wanted to take one of those little manual approvals, you could put it between regions if you really wanted, like region 1 and then a manual approval to go on to region 2, 3, 4. Yeah.
Exactly.
Yeah.
Exactly.
Go ahead.
Question.
Hey, so I have a bit of a general question for the group. I'm actually a university student, and I've worked with cloud for some time. I've mostly on cloud consulting and most recently cloud engineering. I'm pretty platform agnostic. I've worked primarily with Azure, but I've also done work with AWS and Google Cloud in the past. So I'm currently trying to transition to more of a data side and working with data and things like that. So I was wondering if you had any recommendations in terms of resources I could use, especially someone coming from that background to get started and really familiarize myself in that aspect.
Since you use the keyword data, let Nadji answer that.
Well, didn't you have
So I
a
would
book
say-
earlier? Coding is for dinosaurs or something like that? Dan?
Coding is for losers.
Oh,
That's
losers.
such a catchy name. Coding is for losers. But that's kind of
Yeah.
a couple pages to go through. Nothing much.
So I would say, are you interested in data engineering, data architecture? Because even software development, if you want to incorporate the software is evolving from what we used to know to now tools where you integrate like ML as part of your your ecosystem and things like that. Is there a specific area of data that you're interested in, like engineering, architecture?
Primarily data engineering.
Okay, and resources. So I would say Fundamentals of Data Engineering by O'Reilly is grab that, read it, be comfortable. It paints the whole picture as to what data engineering is about, and then start to go down the rabbit hole of the tool stack. And there's lots of tips around figuring out. I mentioned this earlier. Some technology will come and go, but they're a concept that will live forever. So there's an element of data engineering where you have to understand the key concept, because as new tools come online and go offline, the concept will not change. The application, the tool you're using to express those concepts will vary. And so I'd invite you to really be strong on those concepts. Learn the tool as you see. For example, dbt is popular right now. Learn it, use it. Python is a very popular programming language. Be at least good at Python. You can learn Java. You can learn and be good at other languages, but be really good at one. Learn the other, because it's going to be very difficult to be in an environment where everybody uses Python, everybody uses Java. Like, it will vary from organization to organization. So everlasting technology or concept, focus on that. Pick a couple of tools that you're really good at, and then by proxy, you'll be able to deduce how to use other tools. Those are the general principle. And as far as book, Kimball's for sure, and Fundamentals of Data Engineering. Those are the two that you really want to get your hands on. Does that help?
Yes, 100%. Thank you so much.
And find a good mentor, so it's easier, because it's your first job. Everybody will want you. You're not expensive. You're open-minded. Just choose a good company where you can grow the most. So personally, I recommend some startup, smaller companies like two guests we had, because it's easy to get lazy in big companies and learn things the wrong way while you're young. So that's.
I agree with Daniel here. I started with a small company when I got to university. You get exposed to a lot more because by virtue of being small. So you're not siloed. You have to expand on what you know. You have to try things, and that ultimately it's the trial that shapes you. So while you can afford to take risk, go for the startups, go for the small companies now. Really build your skill, and at some point you can decide if you want to remain in that space or for a bigger organization. Some of my friends, we went to university together that started with bigger companies, find themselves very niche, narrow learning knowledge, and then as they transition from company to company, it was more of a struggle to really kind of expand and be more versatile. So I would say, yeah, go for smaller companies to start. You'll learn a lot more because you'll have to do more.
Mm-hmm.
Perfect. Thank you so much.
And then SQL, that's the only language that never died. Learn that.
Yeah.
Yeah.
I was actually just going to mention that. I was going to second a lot of what I've heard here so far. Definitely start at a smaller company if you're younger. I know that's a bit of a hot take, because I'm sure there's folks here who started at big companies who are successful also. But I loved working at a super small company. I was doing a little bit of data engineering before I even knew that that's what it was called. I was getting involved, joining meetups. I found this meetup called Serverless Toronto, and I went to go check it out because they were doing some Lambda stuff. And then this guy named Dan was, obsessed with Lambda, and because I was doing a little bit of everything, I was playing around with Docker containers, and I discovered Cloud Run, and I thought, oh wow, this is kind of cool. It's actually serverless Docker containers. So I tried telling this Dan guy about them, and he was he was a hard sell, but eventually he listened. Also, something I'm going to mention is you don't have to start as a pure data engineer. Kind of another hot take here, because I'm sure a lot of people here did start as pure data engineers. I was starting as like a junior developer at this small company. I was just supposed to do a little bit of whatever they wanted me to do. And because of that, I ended up, doing kind of like half software engineering, half data engineering. I became a generalist, and it really opened a lot of opportunities for me. And I found it very interesting. Like, I was never getting bored. So if you're a university student right now, I mean, that's my personal opinion for like where to go from here is look for a small company where you can do like a little bit of everything.
Very nice.
I'll throw in a couple of online resources, Gautam, just because I'm sort of in a similar stage to you in the sense that I'm only about 12 months to 14 months into my own kind of data journey. And I found that I tell my kids this, that I'm trying to develop data brain. And because I find that working with data is very different from working with almost anything else in the universe, right? Like thinking about tables and how to join them and do inner joins and outer joins and then things like that, and working with SQL and building those advanced queries. It's actually really tough for a lot of people, definitely me, to get good at that and comfortable with thinking like that. And there's a good online school called Data Camp, which just runs tons of path-based training. Some of it is free, and some of it you're going to have to pay for as a monthly subscription, but it's no worse than doing Cloud Guru or anything like that. But they're really good at running you through like batteries of SQL training, and SQL practices and things like that, so that you just get really used to thinking in SQL and thinking about how do I join these tables together to make something more valuable. So something like that is probably worth your time as well.
Perfect. Thank you so
Hey,
much.
while we're talking about SQL, can I show you guys something kind of cool here that I was literally just playing around with? I think it was yesterday morning. It's called Postgres ML. So, with this theme tonight being we can do absolutely everything we need to do with SQL. We've talked about today how we can do data engineering with SQL. You just punch in your data transformation into DBT or BigQuery. So you can actually punch in your SQL to train a machine learning model now, and punch in your SQL to do a prediction. I literally tried this yesterday. I can vouch for it. It works. I put a link in the chat there. It just blows my mind how useful SQL has been.
Yes. But Hugo will tell you about BigQuery ML.
Yeah, they do this in BigQuery, don't they?
Oh, of course. I forgot about that. Classic. Yeah.
Same thing. Like
BigQuery.
suddenly I'm doing forecasting with no knowledge of machine learning.
I mean, I'm sure it helps to have that knowledge. That's yet another hat I'm going to try to wear soon. Try to learn, how this machine learning stuff actually works.
Yeah, there's more and more amazing ML tools for sure. Daniel, we should probably get the draw going soon because we're
yeah. Guys, did you do the Bitly link? So yes, I forgot. I had so much fun listening to everyone. Bitly. Okay. So here's the chat in the chat link again. And then what I was thinking, is Mike still with us? He had to go. Maybe because next month I was just so tired of everything. I didn't plan anything. Maybe we can continue in March if he wants to come back again. And remember when John, when you and I were talking to Cyril and Jacob, it was a massive topic. Like they were telling us it's hard to put it down in 20 minutes. Maybe we can ask him to go deeper. That seemed interesting. And then Nadji, if you're interesting, so we can have part 2 of this meetup with kind of helping people get into data, if there is an interest. So do the form, so for me to collect the names, and then think like if that would be good meetup for the next time to catch up with Mike and the rest of you.
I could definitely be back, Daniel. So just let me know, and yeah.
Hugo, thank you. I'll put your name into the draw as well, Hugo. Thank you so much for doing this. So start doing the form. You don't have to answer every question. I just need the names. And then keep chatting. Shari, thank you so much for taking the highlights of the chat. And sorry, I was mispronouncing the name.
Daniel, this is for the Manning book, is that right?
Yes, yes. Anything. It doesn't have to be a book. It can be course. It can be.
Yeah, no, I was just going to say as a contribution to the chat just now that Manning I'd never heard about until about a month or two ago, and a colleague on LinkedIn got into, he's a quantum computing guy, so he did the Manning course on quantum computing. And so I looked it up, and I'm kind of a junkie now. I've subscribed to Manning, so I can just do any of their courses at any time. And I just find it incredibly useful. And it's not just the live projects themselves, although those are amazing as like end-to-end, you know, go build something and you don't get a lot of hand-holding. But the books themselves are so like incredibly clearly written that like I was just doing an animation of an algorithm the other day, and there's that book Grokking Algorithms that's on there. It's beautifully written and really easy. So you know, that's another great resource for anyone who doesn't know Manning. They're a fascinating publisher.
And they're affordable. That's what I like about them. With the O'Reilly, I run out of money before I get all the knowledge I want. With Manning, you get for the same price. You get both digital editions you can read on Kindle or wherever, any reader, and the print book.
Yeah.
And O'Reilly charges double for everything. So they're more affordable for people around the world. That's what I like.
I've had pretty good experience.
Yeah, you work with them. Yeah, Matt, tell them about that.
Oh no, that's a bit of a long story. I was just going to say my personal opinion of Manning is the books are pretty good, but I went a bit overboard buying them, and I noticed that you do run into a few not so good titles. My rule of thumb, look for like 400 pages or less. The really big ones, they're a little bit too bloated and dry. No offense to the authors, of course. I'm sure they work real hard.
Yeah. And what I've seen with the book authors, because some of them are guests here, so a lot of them use it as learning experience because their reviews and editors are really good. But then they find for second book another publisher who gives them more money. So not too many returning book authors, but for the first time experience, if there's something to say, you can learn a lot from them, but not get rich because the books are cheap. So how are we doing with the raffle form? Let's see responses.
I added myself to it. Maybe to speed this up, what we could do is just have everybody raise their hand here if they still need a minute to enter.
And then let me.
Or if you want, you just share your screen with it, Daniel. And if anyone's not listed there,
Yes. Hang on a sec. Let me copy what I have here.
Yeah.
So today's 27th. So how many people? So you're gonna have good odds of getting the. So share.
Oh, we had good numbers over the course of the night. It's just been a long night. I think a lot of people.
Yeah. And we have two diverse topics. So, but I was surprised we only lost 5 data people, like because these are totally different topics, rarely meshed together.
Yep.
But yet they're similar. Your entire screen. Am I sharing? And then it was Wheel of Names, huh?
Data-related topics into this meetup. Like I think there was data and database and data design related topics. That was great.
How do you spell Wheel of Names?
It's probably got an H in there. Let's see. Yeah, Wheel of Names.
So that's it. Remembers me. Okay. So who else? We have Hugo. Who else is missing from the? Nadji, I see you. Anybody else? I'm going for a spin.
I think that's it. We're down to 15 in the room now, anyways.
Okay. Hey. Congrats.
Right. Nikhil's a
Well deserved.
Remember? Yeah.
Well deserved. Yes,
Yeah,
it's the first meetup, I believe.
Yeah.
Thank you.
All-timer OG. Yeah, thank you. Thanks, guys.
Thank you. So we're going to be wrapping this up. Thanks everyone for coming, and we're going to do then part 2 of this meetup in March in more casual format. Now we know the interest is into helping people without jobs get the jobs and get them closer to probably data. That feels like a good place to be.
Yep. Okay.
Anything
Thank you,
else?
everybody, for coming out. It was a good night. good luck to everyone who's in the job hunt, and we will talk to you next month sometime.
Yeah, I
Thank you.
appreciate
Have a good
those
night.
links that folks threw out for the jobs. I bookmarked those data engineering job posts.
Great, great. Yeah.
Awesome, awesome. Good luck.
Have a great night, guys.
Good night,
Thank
guys.
you.
Thank you.
Thanks,
Good night.
everyone. Lots of fun.
Bye.
Bye.
Ciao.
Okay, fine.